Hey guys, and welcome back to another video. In this video, we will discuss 2.1 arithmetic sequences and series. Alright, so let's get right into it. So to begin with, a sequence is any list of numbers. It's a list of numbers, right? So and usually a sequence follows some type of rule, but it's not necessary. So some examples of sequences is like 2, 4, 6, 8, and so on. Or we could have like 1 factorial, 2 factorial, 3 factorial, 4 factorial, right? It's just any kind of list of numbers that may or may not follow a rule. In these cases, both of these follow a rule, right? This one, each time you're adding 2, and then this time it's just like each factorial. Okay? So then an arithmetic sequence is just a sequence that has a common difference. So what I mean by that is that each term of the sequence is found by adding a specific common difference to the previous term. So some examples are like this right here, right? This is a arithmetic sequence because here our common difference is 2, right? So our d is equal to 2. D will be used to represent our common difference. So d is 2 means that each time, like to get this next number in the sequence, you just have to add the common difference to the previous term. So 2 plus the common difference 2 gives us 4. 4 plus 2 gives us 6. 6 plus 2 gives us 8, and then so on, like that. All right. So let's do some examples with determining if a sequence is arithmetic or not, right? So if we had like 1, 5, 9, 13, so on, is this arithmetic? Well, from 1 to 5, you have to add 4. From 5 to 9, you have to add 4. And from 9 to 13, you have to add 4. So we can be pretty confident this is arithmetic. So yes, it's arithmetic. Let's do another one. Say we had like 2, 4, 8, 16, and so on. Right? So here from 2 to 4, we have to add 2. From 4 to 8, though, we have to add 4. So if there's even like one exception to the rule, then you can automatically deduce that this is not arithmetic. Right? All right. So now let's find the general term of arithmetic sequence. So the first term of a sequence we usually denote as a sub 1, right? For arithmetic sequence. So our first term is a sub 1, and then our second term, a2, we'll call, by the definition of arithmetic sequence, is the first term, previous term, plus the common difference, so plus d. Okay? So then, similarly, a3 is the previous term, which is a2, plus the common difference. But we know what a2 is, right? Because a2 is equal to a1 plus d. So if you substitute this in for a2, we get a1 plus d, which gives us a1 plus 2d, right? And then we can do this one more time. a4 is the previous term, a3, plus the common difference, d. Again, we know what a3 is, because a3 is a1 plus 2d. So substituting that in, we get a1 plus 2d plus d, which gives us 3d. So hopefully we can all see a pattern here, right? So first of all, notice how all of these have a1 in them, right? And then secondly, notice how they're all a1 plus some multiple of d, and that multiple of d is exactly 1 less than whatever term it is. So for example, here is the fourth term, so it's 4 minus 1, which is 3d. And then here is the third term, so the coefficient of d is 3 minus 1, which is 2. Here is 2 minus 1, which is 1, and here it's like, this is a1 plus 0d technically, right? So it's 1 minus 1, which is 0. So in generally, we have an, this should just equal a1 plus n minus 1 times d, right? And we can generalize this even further, and we get an is equal to ak plus n minus k d. All right, and so this is the general form for an arithmetic sequence, the general term. All right, so now let's do some examples where we try to find some terms of arithmetic sequence. So let's say we have some sequence 2, 5, 8, 11, and so on, right? So the first step we have to see is if this is even arithmetic or not. Well, from 2 to 5, you add 3. From 5 to 8, you add 3. And then from 8 to 11, you also add 3. So we can be pretty confident this is arithmetic because the common difference is constant every single time. So our common difference in this case is 3. And if we write down the formula, we have an is equal to ak plus n minus k d, right? So we have to be strategic about how we pick k, because we know the first term, we know the second term, we know the third term, we know the fourth term, but we don't know anything after that, right? And so, oh wait, I almost forgot. We have to, our goal is to find A13. Okay, that's our goal, is what is A13. So we know the first 4 terms, so k can be anything from 1 to 4, right? But let's just keep it simple, and let's say k is equal to 1. So that means that we get a sub 1 right here, right? And a sub 1 is equal to 2. So substituting everything into here, an, which we want the 13th term, so n will be 13, equals a1 plus n minus k, so that's 13 minus 1. And then the common difference is 3. All right. And then we know that a1 is just 2. So we get that the 13th term is just 38, I believe. All right. Okay, good. Let's do another example. This time, however, it'll be a little bit different, right? So instead of them just kind of giving us the sequence and then us finding the term, let's say they give us a couple of terms. So they give us like a4 is equal to 16, and they tell us that a21 is equal to 67, right? And then they want us to find a1 and d. So how do you do this? Well, so let's just write down the formula again, right? So if we set n equal to 21 and we set k equal to 4, then this becomes a21 is equal to a4 times 21 minus 4 times d. We know what a21 is because that's given, and we know what a4 is because that's also given. So that means that once we plug everything in, the only unknown is d, so we can solve for d. So let's do that. Let's do just that. So 67 is equal to 16 plus 21 minus 4 is 17 d, and then solving for d, you get d is equal to 3. Okay, and then now to get a1, we can simply just repeat this process. So we have an is equal to ak plus n minus k times d, and let's see, we want a1, right? So that means that k has to equal 1, and an, we can use either a4 or a21, it's up to you, but let's use a4, right? So if we set n equal to 4 and k equal to 1, we get a4 is equal to a1 plus 4 minus 1 times the common difference, which we know is 3. And like we said, a4, we already know what it is, it's 16. So we can just replace this with 16. And then now the only unknown is a1, so we can solve for a1. And you should get 7. Okay, good. And actually, now that we have this information, we have the first term and have the common difference, we can actually construct the sequence. So basically, what I mean by that is we know the first term is 7, right? So to get the next term, you just add 3 to 7, so you get 10. And you keep doing that. 10 plus 3 is 13, 13 plus 3 is 16, and it keeps going like that for forever. And notice that the fourth term in this sequence is 16, which is exactly what we want. All right. Okay, cool. So now let's move on to series. So basically, a series is just like adding the terms of a sequence. So it's like adding the terms of a sequence. So if we had like the previous example was 7, 10, 13, and 16, then what a series is you're basically replacing all these commas with plus signs. Okay, so it just keeps going like this forever. So there's two key things about a series, right? So the first thing is converge, and then you have diverge. So what does this mean? So we say a series converges if it approaches a certain value. So for example, if we had like 1 plus a fourth plus a ninth plus a 16th and so on, this would approach a certain value, right? This doesn't just keep going on to infinity. This would approach like some value. So that means we say that this series right here converges. On the other hand, diverges means it doesn't approach a certain value, right? It just keeps growing or keeps decreasing, right? So for example, this series right here, if we had 7 plus 10 plus 13 plus 16, I think it's really clear to see that this would just keep growing and growing and doesn't approach a certain value. So this would just, we say this series diverges. Okay. So now let's talk about arithmetic series. So an arithmetic series is exactly what you think it is. It's just like the sum of arithmetic terms. Right? So this is a finite series because it terminates, right? It ends. You could have infinite series though, which means that this will just keep on going forever. So all finite series converge. All right, all finite series converge. But all infinite series can converge or diverge, right? So that's when like converge and diverge is mainly used when we're dealing with infinite series because all finite series will converge, right? Because they're gonna terminate at some point. So you're gonna end up with some value. But when we're dealing with infinite series, that's when we have to see whether it converges or diverges. Okay. But yeah, anyway, a arithmetic series is just adding up the terms of an arithmetic sequence. So now let's try deriving the general formula for the arithmetic series. So let's say this is a Sn is the arithmetic series, and we know like in how we just discussed that a2 a3 like a2 is just a1 plus d, right? A3 is a1 plus 2d, and so on. So if we just rewrite this as a1 and then plus a1 plus d and then plus a1 plus 2d and so on, and then we can also rewrite this because this is the same thing as if we just flipped it, right? So if we started at an and then plus an minus d plus an minus 2d and so on, right? Until like a1. So hopefully we can agree that both of these are equivalent, right? Because here we just flip the order of addition, which is allowed. So now what we're going to do is I'm going to subtract these two equations. Or sorry, I'm going to add these two equations. So then on the left-hand side, we get 2 times Sn. And then on the right-hand side, a1 plus an. So we get a1 plus an. And here we have a1 plus d plus an minus d. So the plus and minus cancels. So you just have a1 plus n. And same thing happens here. So you just have a1 plus an. And this just continues, right? It just continues. So the question is, how many a1 plus an terms do you have? Well, in our original series, we went from a1 to an. So this has n terms, right? So this has n terms, meaning that this should also have n terms. So if we have n of a1 plus an, how can you represent that mathematically? We can use multiplication. So this is just the same thing as n times a1 plus an, right? This is saying that we have n terms of a1 plus an. And then solving for Sn, divide both sides by 2, you get Sn is equal to n over 2 times a1 plus an. And this indeed is the formula for an arithmetic series. Okay? Alright, good. So now let's do some examples. So I'll use sigma notation. So basically, if I give you something like this is basically just saying the sum as k goes from 1 to 100 of k. So this is just like saying 1 plus 2 plus 3 and so on all the way until 100, right? So first of all, notice how this is an arithmetic sequence, because each time to get the next term, we're just adding 1, right? And so on. So we can use the formula we just found for the arithmetic series was n over 2 times a1 plus an. Okay, so n is the number of terms in the sequence. Well, if you're going from 1 to 100, that means you're going to have 100 terms, right? So n is 100. And then a1 is just the first term, so in this case 1. And an is the nth term, which is just, in this case, a100. But a100 is just 100. Okay? So if you evaluate this, you should get 5,050. So we just found the sum of the first 100 numbers, like almost like super fast. I think that's pretty cool. Right. All right. Let's do another example. So this time, let's say we have the sum as k goes from 1 to 20 of 2k plus 1. Okay, so first let's write out the first few terms of the sequence, right? So when k is equal to 1, you get 2 plus 1, so that's 3. When k is equal to 2, you get 2 times 2, 4 plus 1 is 5. 3, you get 7, and it keeps going like this until 20, so that would be like 41. Okay, so notice how this is an arithmetic sequence or series, because each time we're adding 2 to get the next term. All right, so we can just use the formula for arithmetic series. And n is the number of terms. How many terms do we have? Well, we're going from 1 to 20, so we just have 20 terms. Okay. Let's see, 20 over 2 is 10. A1 is the first term, which we found was 3. And then A20 is the 20th term, so that's just the last term, which is 41. Okay. And evaluating this, you should be get 440. Okay. All right. Nice. So yeah, that's pretty much it for arithmetic sequences and series. If this video helped you, please make sure to subscribe so you don't miss any future videos. And I'll see you guys in the next video.